Hello dear students, all of you welcome to Vidyan classes. Today we will discuss Cramer's rule, consistency, inconsistency and a number of solutions of a system of linear equations. First, Cramer's rule for three unknowns x, y and z. What is Cramer's rule? Statement. For a system of linear equations, for a system of linear equations, a1x plus b1y plus c1z is equal to d1, a2x b2y plus c2z is equal to d2, a3x b3y plus c3z is equal to d3. These are the linear equations. Implies as x is equal to del 1 by del, y is equal to del 2 by del, and z is equal to del 3 by del, where del is the determinant having elements a1, a2, a3, b1, b2, b3, c1, c2, c3 not equal to 0. Del 1 is the determinant having elements d1, d2, d3, d1, d2, d3, b1, b2, b3, c1, c2, c3. Del 2 is the determinant having elements a1, a2, a3, d1, d2, d3, c1, c2, c3, and del 3 is the determinant having elements a1, a2, a3, b1, b2, b3, d1, d2, d3. It is the statement of Cramer's rule for a system of linear equations. Linear equation means 5-degree equations. That means the power of x, y and z are 1. The power of x is 1, the power of y is 1, the power of z is 1. So, these are the linear equations. For a system of linear equations, x is equal to del 1 by del, y is equal to del 2 by del, and z is equal to del 3 by del, where del is the determinant having elements a1, a2, a3, b1, b2, b3, which is not equal to 0. Del 1 is the determinant having elements d1, d2, d3, b1, b2, b3, c1, c2, c3. Del 2 is the determinant having elements a1, a2, a3, d1, d2, d3, c1, c2, c3, and del 3 is the determinant having elements a1, a2, a3, b1, b2, b3, d1, d2, d3. It is the statement of Cramer's rule. These are the system of linear equations. If these are the system of linear equations, implies this x is equal to del 1 by del, y is equal to del 2 by del, and z is equal to del 3 by del, where del not equal to 0. Del contains the coefficients of x, y and z. A1, A2, A3, B1, B2, B3, C1, C2, C3 not equal to 0. Proof. These are given. Del is equal to determinant having elements A1, A2, A3, B1, B2, B3, C1, C2, C3. Clear? Del is the determinant having elements this. Implies del x is equal to x into A1, A2, A3, B1, B2, B3, C1, C2, C3, which is same as, which implies del x is equal to determinant having elements. Whenever a scalar is multiplied with a determinant, then it will be multiplied in any one of the rows or columns. Now multiplying x along column 1. It gives a1x, a2x, a3x, b1, b2, b3, c1, c2, c3. X is the scalar is multiplied with a determinant del. So x can be multiplied in any one of the rows or columns. Multiplying x along column 1 del x gives well this. Apply column 1 is replaced by column 1 plus y times of column 2 plus z times of column 3. Capital C1, C2, C3 represent the columns. Small c1, c2, c3 represent the elements. Del x is equal to column 1 is replaced by column 1 plus y times of column 2 and z times of column 3. It gives a1x plus b1y plus c1z. Column 1 y times of column 2 plus z times of column 3. a2x b2y plus c2z. a3x b3y plus c3z. Column 1 is replaced by column 1 plus y times of column 2 and z times of column 3. b1, b2, b3, c1, c2, c3. Clear? Capital C1, C2, C3 represent the columns. Small c1, c2, c3 represent the elements. Column 1 is replaced by column 1 plus y times of column 2 plus z times of column 3. It is a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3, which is same as d1, d2, d3. b1, b2, b3, c1, c2, c3, which is equal to, it is given by del 1. This determinant is taken as del 1, which is equal to del 1. Implies this del x is equal to del 1, which implies this x is equal to del 1 by del. So x is equal to del 1 by del, where del not equal to 0. Clear? Okay. Next, del is equal to determinant having elements a1, a2, a3, b1, b2, b3, c1, c2, c3, which implies this del y is equal to yg multiplied with del. If a scalar is multiplied with a determinant, then it will be multiplied in any one of the rows or any one of the columns. Suppose y is multiplied along column 2. It gives multiplying y along column 2. a1, a2, a3, b2y, b3y, c2, c3. Del is given by this, multiplying y with del, that means y is multiplied along column 2 by the properties of determinant. Applying column 2 is replaced by column 2 plus x times of column 1 and plus z times of column 3. Capital C1, C2, C3 represent the columns. Small c1, c2, c3 represent the elements of the determinant. Implies this del y a1, a2, a3. No change of column 1 and column 3. Column 2 is replaced by column 2 plus x times of column 1 plus z times of column 3. So it is a1 x plus b1 y plus c1 z. a2 x plus b2 y plus c2 z. a3 x plus b3 y plus c3 z. c1 c2 c3. Column 2 is replaced by column 2 plus x times of column 1 and z times of column 3. Implies this del y is equal to determinant having elements a1, a2, a3, a1x plus b1y plus c1z is equal to d1. d1, it is d2 and it is d3. c1, c2, c3, which is same as this determinant is del 2, which is del 2. Implies del y is equal to del 2. Implies y is equal to del 2 by del, where del not equal to 0. The denominator is not equal to 0. Similarly, del z is equal to del 3, that implies z is equal to del 3 by del. Clear? Similarly, we can prove del z is equal to del 3, del is equal z is equal to del 3 by del. Therefore, for the system of linear equations, for a system of linear, for a system of linear equations, a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. This system implies x is equal to del 1 by del, y is equal to del 2 divided by del, and z is equal to del 3 divided by del. This represents a system of linear equations. That means finite equations. Implies x is equal to this, y is equal to this, and del z is equal to this. Hence, proved. Clear? Clear? Okay, write down. Next, consistency, inconsistency, and the number of solutions of a system of equations. System of linear equations. From the Cramer's rule, we have for a system of linear equations implies x is equal to del 1 by del, y is equal to del 2 by del, and z is equal to del 3 by del. At what condition the system of linear equations is said to be consistency, inconsistency, and how many solutions in the system of equations? First, consistency. A system of linear equations is said to be consistent if del is not equal to 0. A system of linear equations is said to be consistent if del not equal to 0. The denominator is not equal to 0. That means x is exist, y is exist, and z is exist. A system of linear equations, that means these equations said to be consistent if del not equal to 0. X, y, and z are exist. That means solution of the linear equations exist. Del is not equal to 0 implies the system of linear equations has unique solution. That means unique means one and only one solution. Since the denominator not equal to 0, x, y, z are exist. That means the system is consistent if del not equal to 0. For del not equal to 0 implies the system of linear equations has unique solution. Unique solution. The system of equation is consistent means the solution is exist and it is only one solution. It has only one solution. Clear? Next 2. Inconsistent. A system of linear equations is said to be inconsistent. Inconsistent. A system of linear equations is said to be inconsistent if del is equal to 0 and 1 if del is equal to 0 and at least one of del 1, del 2, del 3. A system of linear equations is said to be inconsistent if del is equal to 0 and at least one of del 1, del 2 and del 3 is non-zero. Del is equal to 0. Suppose x is equal to del 1 by del. Del is equal to 0 and del 1 not equal to 0, which approaches to infinity. The denominator is 0 and numerator is not equal to 0. So x approaches to infinity, which is not a solution. X does not exist. From the definition, it is clear that a system of linear equation is inconsistent if del is equal to 0 and at least one of del 1, del 2 and del 3 is non-zero. Implies inconsistent implies the system of equations has no solution. The system is consistent implies the system has unique solution. It has unique solution. If the system is consistent, that means del not equal to 0, it has unique solution. If the system is inconsistent, this is the condition, del is equal to 0 and at least one of del 1, del 2 and del 3 is non-zero, implies either x or y or z or both or all are infinite. Del 1 not equal to 0, del is equal to 0, x approaches to infinity is not a solution. So inconsistent implies the system of equations has no solution. For consistent, the solution is exist. For inconsistent, the solution does not exist. Clear? Okay. Next. If del is equal to del 1 is equal to del 2 is equal to del 3, then the system of linear equations, the system of linear equations has the system of linear equation will have infinite number of solutions. Infinite number of solutions. Since 0 into 1 is equal to 0, that implies 0 by 0 is equal to 1. 0 into half is equal to 0, that implies 0 by 0 is equal to half. 0 into minus 2 is equal to 0. 0 by 0 is equal to minus 2 and so on. 0 into 1 is equal to 0, that implies 0 by 0 is equal to 1, 0 into half is equal to 0, 0 by 0 is equal to half, 0 into minus 2 is equal to 0, 0 by 0 is equal to minus 2 and so on. It is clear that 0 by 0 is any number. 0 by 0 is any number. If del is equal to 0, del 1 equal to 0, del 2 is 0 and del 3 is equal to 0, all are 0. If del is equal to del 1 is equal to del 2 is equal to del 3 is equal to 0, then the system of linear equations will have infinite number of solutions, since x is in the form of 0 by 0, y is in the form of 0 by 0 and z is in the form of 0 by 0. 0 by 0 is any number, that means 0 by 0 is any real number. So, if del 1, del 2, del 3 all are 0, then the system of linear equations will have infinite number of solutions, since it takes the form of 0 by 0, where 0 by 0 is any number. Clear? X takes the form of 0 by 0, x is any number, any real number which is infinite. There exists infinite number of real numbers. If y equal to 0 by 0, y takes infinite number of real numbers, z is equal to 0 by 0, z takes infinite number of real numbers. So, the solution, it has infinite number of solutions. If del is equal to del 1 is equal to del 2 is equal to del 3 is equal to 0, then the system of linear equations will have infinite number of solutions. Clear? Clear? Okay. Next. 4. If del not equal to 0, del 1 is equal to del 2 is equal to del 3 is equal to 0. If del not equal to 0, del 1, del 2, del 3 is equal to 0, that means something del not equal to 0, del 1 0 by something equal to 0, 0 by something equal to 0 and 0 by something equal to 0. Del not equal to 0. Then xyz is equal to 0, 0, 0. The solution of the system of linear equation is 0, 0, 0. X 0, y 0 and z 0 is called trivial solution of the system of linear equations. Is called trivial solution. If x equal to 0, y equal to 0 and z is equal to 0. If del not equal to 0, del 1 equal to 0, del 2 equal to 0, del 3 equal to 0, that implies xyz all are 0 is called trivial solution of the system of linear equations. Clear? 5. If del not equal to 0, at least one of at least one if del not equal to 0, at least one of del 1, del 2, del 3 if del not equal to 0, at least one of del 1, either del 1 not equal to 0, at least one of del 1, del 2, del 3 is non-zero, then the solution is called non-trivial solution. Then the solution is called non-trivial solution of the system of linear equations. If del not equal to 0 and at least one of del 1, del 2, del 3 is non-zero, then the solution is called non-trivial solution. It is called non-trivial solution of the system of linear equations. If xyz all are 0, then the solution is exist, that is consistent. If xyz all are 0, the solution is exist, that is consistent, and the solution is called trivial solution of the system of linear equations. If del not equal to 0, that means denominator not equal to 0, at least one of del 1, del 2, del 3 is non-zero, then the solution is called non-trivial solutions of the system of linear equations. Linear equations. Clear? If all are 0, that means x0, y0, z0, then the solution is called a trivial solution. If at least one of them, at least one means either x is not equal to 0, y not equal to 0, z not equal to 0, or xy not equal to 0, yz not equal to 0, all are not equal to 0, then the solution is called non-trivial solution. Clear? Clear? Okay. Write down. Elements of Mathematics, Class 12, Exercise 5B, page number 148. Question number 1, write the number of solutions of the following system of equations. First bit, x minus 2y equal to 0. X minus 2y is equal to 0, that implies y is equal to x by 2. For x is equal to 0, that implies y is equal to 0. X is equal to 1, that implies y is equal to half. X is equal to minus 1, that implies y is equal to minus half. And so on. Implies 0, 0 order pair, 1 half order pair, minus 1 minus half order pair dotted are the solutions of x minus 2y is equal to 0. Therefore, number of solutions of x minus 2y is equal to 0 is infinite. Number of solutions of x minus 2y equal to 0 is infinite. These are the solutions of the given equation. Here is a note. If the number of equations of the system if the number of equations of the system is less than the number of variables, then the number of solutions is infinite. Here the number of equation is 1 and the number of variable is 2, that is x and y. The number of equation is 1, number of variable is 2. Number of equation is less than the number of, if the number of equations of the system is less than the number of variables, then the number of solution is infinite. X and y are two variables. X minus 2y is equal to 0 is the equation. Number of equation is 1, number of variable is 2. So it has infinite number of solutions. Clear? Second bit, x minus y equal to 0 and 2x minus 2y is equal to 1. This and this are two straight lines. L1, let L1 be the first line and L2 so that 2x minus 2y is equal to 1 is the second line. Solution by first method, method 1. By Cramer's rule, del is the determinant having elements, the coefficients of x and y. Here x is the coefficient of x is minus 1 and minus 2. 2 plus 2 is equal to 0. Clear? Del 1 is the determinant. D1, D2. D1 means 0, D2 is 1, 0 and 1. Minus 1, minus 2. Which is same as 0 plus 1, that is equal to 1, not equal to 0. Del 2 is the determinant 1 to D1, D2, that is 0, 1, 0 and 1, which is also 1, not equal to 0. Clear? Since del is equal to 0, del 1 is equal to del 2, not equal to 0, implies this. X represents del 1 by del, which is infinity. Y is del 2 by del, which is infinity. Infinity is not a solution. Implies this. The system of equations has no solution. No solution. Or we can say number of solutions of the system is 0. The system of equation has no solution, or we can say the number of solutions of the system is 0. Method 2. First method is the Cramer's rule. Second method using coordinate geometry. Slope of first line, slope of L1 is M1, which is equal to minus A by B, that is equal to 1. A by B, A is 1, B is minus 1, minus A by B, that is equal to 1. Slope of L2 is M2 minus A by B, that is equal to 1. Implies M1 is equal to M2, that implies L1 parallel to L2. That implies no point of intersection. Implies no solution. Since Slope of first line is equal to slope of second line. That means two lines are parallel. Implies this no point of intersection. Since the two lines are parallel, they have no point of intersection. Point of intersection represents the solution. Since there is no point of intersection, the system equation has no solution, or number of solution is 0. Clear? Okay. Next, third bit. Solution. 2x plus y is equal to 2 is the first line. Two x plus y is equal to minus 6 is the second line. L2 say is the second line. This is L2. Let L1 is the first line and L2 is the second line. Method 1. By Cramer's rule, del is the determinant having elements coefficients of x and y, that is 2, 1, 1, which is equal to 0. Del 1, the first column contains coefficients of x. Del 1 contains the coefficients. Del 1 contains d1, d2. Sorry, that is 2 minus 6. And 1, 1. Which is same as 2 plus 6 is equal to 8, not equal to 0. Del 2 2 and d1, d2. d1, d2 means 2 minus 6, which is equal to minus 12, minus 4, minus 12, minus 4, which is equal to minus 16, not equal to 0. Clear? Del 2, coefficients of x and d1, d2. d1 means 2, d2 means minus 6. Minus 12, minus 4, which is same as minus 16, not equal to 0. Since del is equal to 0, del 1 not equal to 0, del 2 not equal to 0, by Cramer's rule, it implies the system of equations. A system of equations has no solution. No solution. Or the number of solutions is 0. Clear? Method 2, that is coordinate geometry method. Slope of L1 is equal to M1 minus A by B, that is equal to minus 2. Slope of L2 is equal to M2 is equal to minus A by B, that is minus 2. Implies M1 is equal to M2. Slope of first line is equal to slope of second line. Implies L1 parallel to L2, which implies since two lines are parallel, there is no point of intersection. No point of intersection. Therefore, the system of equations has no solution. It is the codeterminant method, it is the determinant method using Cramer's rule. Second method, that is a coordinate geometry method, is easier to find out the number of solutions. The system equations has no solution. Clear? Clear? Okay, write down. Next, fifth bit. 2x plus 3y plus 1 equal to 0 and x minus 3y minus 4 equal to 0. Let L1 be the first line, so that 2x plus 3y plus 1 is equal to 0. And L2, so that p minus x minus 3y minus 4 is equal to 0 is the second line. Then we represent the determinant having elements coefficients of x and y, that is 2, 3, 1 minus 3, 1 minus 3. The value of the determinant minus 6 minus 3, that is equal to minus 9. Del 1 is the determinant. D1 means minus 1. D2, that is equal to 4. 3 minus 3, which is same as 3 minus 12, that is equal to minus 9. Del 2 is the determinant having elements coefficients of x and d1, d2 minus 1 and 4, which is same as 8 plus 1, that is equal to 9. It is not equal to 0, it is also not equal to 0. X is equal to del 1 by del. Del 1 by del, that is 1. Minus 9 divided by minus. Y is equal to minus 1. Del 2 by del. XY order pair represent the solution, which is equal to 1 and minus 1. The number of solution is 1. Therefore, it has one solution. It is the first method. Method 1. Using Cramer's rule, we get the system equation has one solution. Method 2. Using coordinate geometry. The slope of the first line, slope of L1 is M1, which is minus a by b, that is equal to minus 2 by 3. Slope of L2, which is M2, is equal to minus a by b, that is 1 by 3. A is 1, b is minus 3, so it is 1 by 3. M1 not equal to M2 implies L1 is not parallel to L2. Since L1 and L2 are not parallel, they will intersect. Implies L1 and L2 intersect each other at one point. Since L1 and L2 are not parallel, they must intersect each other at a point. So the number of solution. Therefore, number of solution is 1. L1 and L2 are not parallel. It is L1, it is L2, they intersect each other at a point. That point is 1 and minus 1. The point of intersection represents the solution of the system of equations. L1 and L2 intersect each other at a point, so the number of solution is 1. Clear? Okay. Sixth bit, x plus y plus z is equal to 1, x plus y plus z is equal to 2, 2x plus 3y plus z is equal to 0. Del is the determinant having elements the coefficients of x, y and z, that is 1, 1 and 2. 1, 1, 3. 1, 1, 1. Which is same as 0, 0, apply. C1 is replaced by C1 minus C2. C2 is replaced by C2 minus C3. 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0, 2 minus 3, that is equal to minus 1, 3 minus 1, that is equal to 2. 1, 1, 1. C1 is replaced by C1 minus C2. C2 is replaced by C2 minus C3. 1 minus 1, 0, 1 minus 1, 0, 2 minus 3 minus 1, 1 minus 1, 0, 1 minus 1, 0, 3 minus 1, that is 2. Column 3 remains silence. Expanding along row 1. It is 0 minus 0 plus 1. Deleting the corresponding rows and column of 1. It gives 0, it gives 0, 1. 0 minus 0, which is equal to 0. Implies del is equal to 0. Clear? Okay. Del 2. Read del 1. D1, D2, D3, 1, 2, 0. 1, 2, 0. 1, 1, 3. 1, 1, 1. Which is same as applying C1 is replaced by C1 minus C2. C2 is replaced by C2 minus C3. It gives 1 minus 1 that is 0, 2 minus 1 that is equal to 1, 0 minus 3 minus 3, 1 minus 1 0, 1 minus 1 0, 3 minus 1 2, 1 1 1. Row 1 contains maximum zeros expanding along row 1, which is 0 minus 0 plus 1, 2 minus 0 that is equal to 2 not equal to 0. Del not equal to 0. Sorry, del 1 not equal to 0. Clear? Expanding along row 1. 0 minus 2 minus 0 that is 2, 2 not equal to 0. Del 2 1 1 2 coefficient of x d1 d2 d3 that means 1 2 0 1 1 1. Again replacing C1 is replaced by C1 minus C2. C2 is replaced by C2 minus C3. Del 2 is equal to 1 minus 1 0, 1 minus 2 minus 1, 2 minus 0 that is equal to 1 minus 1 0, 2 minus 1, 2 minus 1 that is equal to 1, 0 minus 1 that is equal to minus 1, 1 1 1, which is so much, it gives 0, it gives 0, 1, 1 into 1 minus 2 which is equal to 1 minus 1 not equal to 0. Del 2 not equal to 0. Del 2 not equal to 0. Next, del 3 1 1 2 coefficient of x, coefficient of y 1 1 3 and 1 1 1. Sorry, it is d1 d2 d3. d1 d2 d3 that is 1 2 0. Which is same as del 3 is equal to 1 minus 1 0, 1 minus 1 0, 2 minus 3 minus 1, 1 minus 1 that is 0, 1 minus 2 that is minus 1, 3 minus 0 that is equal to 3, 1 2 0. C2 is C1 is replaced by C1 minus C2. C2 is replaced by C2 minus C3. Expanding along row 1, it gives 1 0 minus 0 1 0 minus 1 which is equal to minus 1. It gives 0, it gives 0, 1 into its minor. That means the sign of 1 is positive into its minor. The value of this determinant 0 minus 1 which is not equal to 0. Now, which implies this del 3 not equal to 0. Now we have del is equal to 0. Del is equal to 0. Del 1 not equal to 0. del 2 not equal to 0, del 3 not equal to 0. That means x approaches to infinity, y approaches to infinity, and z approaches to infinity. As x is equal to del 1 by del, y is equal to del 2 by del, the denominator is 0, the numerator is not equal to 0, so x, y and z are not defined. Therefore, the system the system of equations has no solution. Since del is equal to 0, del 1 not equal to 0, del 2 not equal to 0, del 3 not equal to 0, that implies x tends to infinity, y tends to infinity, and z tends to infinity. So x, y and z are not defined. So the system equation has no solution. That means the number of solution is 0. The number of solution is 0. Clear? Clear? Okay, write down.